Hello student, how are you? Dr. Shiva here. Good day to all of you. This week we will continue for the matrix, and since next week is your last day for the PNP teaching and learning, we will try to cover the whole syllabus as much as possible. And matrix today that I'm going to cover the system of linear non-homogeneous equation, and there are a few more area to just cover, then we can complete the whole syllabus. After next week onwards, then you will be evaluated with the tests and assignments. Okay. Anyway, how are you? All of you doing good? I hope that take care of yourself. Let me start the session. Okay, today I'm going to cover the system. Okay, the system of linear equation, linear non-homogeneous equation. Okay, equation. Okay, non-linear non-homogeneous equation. Okay, what is this system of linear non-homogeneous equation? Okay, it is basically can be assigned as something like ax to the b, whereby a is a matrix and x, okay, I'll let you know that is a variable, and this is the answers. Okay, maybe I'll try to write this. If we can write that as inverse to find the solution of variables. For example, let us see one simple example that which you already learned before. Okay, we already learned the linear equations, okay, solving, but now we are solving the three variables. Okay, 2x plus 5y plus z plus negative 5 negative 5 and x plus 2y plus 3z is a 6. Okay, this equation, in order to find the equation, we can use a simple matrix concept. Okay, 1 3 1, you just pick 1 3 1 2 5 1 2 5 1 1 2 3 1 2 3, then just equate that to the x y z. Okay, then you just write the answer, not to say the answer, actually the solution for that. And now we're going to find, this is we call as a and this is we call as a x, and this we call as a b. Okay, now you can see this is what we call it as a system of linear non-homogeneous equation. Okay, now in order to solve this, there are various methods has been introduced in matrix, and we're going to see few, and one of the simplest method is we call it as a inverse method. Okay, inverse method, which we have done before. Basically we just say x, we can okay, let me put it here like this. Okay, let's say I wanted to find out the x, what is the answer for the x y z. Okay, then it's easy, then I can introduce what we call as inverse of a to times with us, and immediately I will get here negative 1b. That means this is, we know, is identity times with the x, we will get back the x. Okay, again I just write this again, is x is equivalent to the negative x to the b, where we get a x a negative to the b. This is how to solve. That means in order to find the ax equals to b, that means you wanted to try to identify what is the solution for x y z, you need to get a inverse of a times with the b, you will get x y z, the answer for the x y z. This is what we call as a inverse method. Okay, we call it as a we use a inverse method. Okay, inverse method, which I will not go into detail. Okay, I will not go into detail. Okay, some of you may be curious to know why we use many methods, since this is one of the good method. Is it a good method? No. There are a lot of setback when we learned this matrix and system, linear system. There are a lot of setback when we start using this kind of calculations. Numerically, it's not. Sometimes it's feasible to solve, or it's not. What do you call? Sometimes it might be a very time consuming. Therefore, people invented many different methods to solve these problems. Okay, linear method problems. That is one of the wonders lah. Because people spend a lot of time to identify. But when we start doing this manually, you may find it difficult. But actually, when you give it to computer, it will do that very comfortably. Okay, but we are learning the technique. Actually, what we are learning, we're going to learn is a technique of computer system. Okay, how the computer actually able to solve this problem very efficiently. Okay, but when we give it to this it will take a longer time to solve, because you need to find the determinant, and after that we need to convert that to the what you call similar. But I'm not going to compare, because when you compare that the computational time is a matter here. It's not I decide or anybody decide to say this is better or this is good, but depends on the question and the problem that we are solving. Then some method will be very efficient, some method are not. Okay, the second method we will go for what we call as a Cramer methods. This is what we have done previously several times. Okay, the Cramer methods actually we have done for the variation method. If you can still remember Cramer's rule. Okay, Cramer's rule. If it works, if it is the determinant is not 0. Okay, if determinant is not 0, okay, we take a same problem. Okay, the same problem, and we just able to solve this very fast. From my point of view, this is what we did for the what do you call variational method. Okay, when we solve variational method. Okay, you see, I'll start writing this very fast. The solution is like look very simple actually. A, we can solve the answer. I will also give for that one later. I'll give you what is the solution, what are we solving. Okay, some of you may ask, sir, I didn't get it, what is this A1, A2? Give me 1 minute. I will fill up this first. Okay, because the solution is, it will able to solve this. Okay, now let me show you what is A1, what is A2, what is A3. Okay, we have done this before. Okay, I hope that you can follow this for a while. You just copy this first. Okay, you just copy this. Okay, just answers, because some of you may say, so I already learned this before. Okay, in my form 5 or something, that which I can solve manually. But don't use that method. Okay, don't try to use that one. Okay, because if the things become complex, you won't be able to solve it by the way that the traditional way that solving the 2 equation, then after that move to the 3rd equation. No, don't do that. Okay, it's then it will then you won't be able to solve certain problem at all. Okay, now let me go through the A. Okay, A1. What is A1? A1, okay, first you need to, you see, I'll just teach you. You just throw this one, okay, the B into the A. Okay, let me show you. Okay, you need to take a determinant of the determinant. Just take a -2, -5, 6, 3, 5, 2, 1, 1, 3. Okay, what am I doing here? Look at this. I'm taking the B and placing in the first column of A. I call it as a A1. Okay, then I find the determinant of this. Okay, and I get the solution for this as a -3. Okay, now no more we will teach how do you solve. Maybe you can use calculator or whatever, no problem, but please learn how to find the determinant anyway. A2, similarly you go to the column 2. Okay, then you just able to solve that as a okay, remember that I forgot to put this is coming from the B. Okay, this is -2, -5, 6. Okay, this is B anyway. Okay, 1 3. Okay, then you solve, you get a 6 as your solution. Is it a 6 is the solution? No, something wrong. I haven't divided that. I haven't divided that yet. Okay, and A3, similarly you just start doing that 1 2 1 3 5 2, and now you place this B. Okay, the B -2 -5 6. Okay, B, and you get a -9. Okay, then you need to find A. Okay, okay, sorry. Anyway, remember, this is all you need to find the determinant. Okay, in order to find the determinant again, you just continue with the 1 3 1 2 5 1 1 2 3. Okay, then you get a -3. Okay, when you try to solve, you get the solution of this. Okay, am I fast? I hope that you can copy. It's not difficult. You can try by yourself. Okay, but most important, you can just verify your answer with this. Done. Okay, now the next thing that we're going to do is ranking. We won't go into too detail, when we work on the ranking. Ranking is one of the powerful method to solve many problem as well, but rank will contribute, but at least I will try to teach you, because I think last year something to do with the matrix came out, if I'm not wrong. Okay, very simple. Please master. I'm not going to spend more time for this rank. Okay, A equals to rank is a 4 2 3. For example, 0 0 0 0 0 0. Okay, then the rank for this is A1. Okay, the rank is 1. The detail you can get, I want you to a little bit to go through the rank detail. Okay, but I will give you certain properties detail. RA is can be again solved with the AT, and number 2, we can solve R. We can solve the R equals to 0. Okay, if you take it empty. And the most important things here, this. Okay, if A m times with the end, the R rank to the A is a less than minimum m to the n. Okay, if any this what you call m times n, the rank of A will be, we can identify based on the mean mn. Okay, this is a very important one. I think I'm jumping very fast. I know some of you may please do some simple revision. If end, the rank is end, then we equate that to the A not equals to 0, we call that as a non-singular. This is very important. Non-singular. Okay, I already explained to you what is singular, non-singular, right? Okay, but depends how do we interpret the rank for the A if it is a less than end. If you find out all 0, okay, and the end, okay, for the end, if 4 by 4, for example, there is a one rank less than for the RA, then we can just conclude A is a 0. It's understood, right? We already before told you, if there is a one single row or single column involve all 0, then automatically the determinant of that will be 0. Okay, therefore, and in this particular case, can you imagine if a rank is less than end for the A, which is n times n, it's understood one of the rank is a 0, then immediately we know is singular. Okay, is singular. Okay, now if this is the scenario, now we're going to this is a basic kind of things that which I want you all just to understand the basic things about ranking. Okay, rank, how to identify the rank for especially non-singular. You can see for the R is all non-zero is exists, then immediately we know is not 0 and non-singular. Okay, now in this particular case, if you solve A with the identity, this is what we did before. Okay, this is what we did before. If we transform that to the identity to the A, which is non-singular, we can see if we can do this. Okay, this is a non-singular. Okay, it's non-singular. Okay, and R A for the rank must be end if A n times end. This is one way to solve the problem. Now we move on, okay, to the system of linear non-homogeneous concept, and we have done for the linear system of linear non-homogeneous non-homo equation. For the A times X, we're going to learn one method which is quite popular in our schools, in our engineering school teaching, especially for the mathematics. We already, okay, this is the method. We learned so far, this is the method to solve, of course. Okay, we are trying to find out in order to solve the linear system, we need to use this. Okay, we learned 3 so far. We use inverse. Okay, we use inverse method. We use Cramer method. Okay, they might be a lot, but I am not going to focus so much into many other system. Okay, what the next one that we're going to learn is LU decomposition method. Okay, then this is A. There are 2 types. One we call as a Kraut's method, LU method, factorization. Another one we called as a Doolittle. You may find it both looks same, but except the way that we are solving the things, both are same actually. Not much, but the contributions makes a lot of difference between these 2 solutions. Okay, now what is LU? First we need to understand what is LU. Okay, lower diagonal and upper diagonal. Okay, we're going to see what is the difference between lower diagonal and upper diagonal. I use the same paper. in case it's easy that I can come back again. Okay, you can be considered as okay, any numbers like 0 for the 3, yeah, 3 by 3, 0, 0, and 0, 0, 0. Okay, you can see this. If you notice something, then over here can be any number. Any number, we don't care. Okay, then this is we call upper diagonal, because the upper diagonal exists numbers. Lower, no, 0. As the same thing for the lower, we just we use a similar method here. Over here, then 0, 0. Okay, is it the first two? If we move on for the, see, 1, 2. Okay, the first one supposed to be 3. I try to make it a 3 first. Okay, then okay, I made a mistake here. Okay, 1, just the upper part to make it the similar examples. Okay, in this case 2, 2 and 1. Okay, imagine that is something that we can say, okay, it's moving like this. Okay, rest is there is answer is going on in this side. Okay, this is lower. Okay, it can be 4. Don't ask me why 3, why 2, these things. Just I'm introducing the logics for you. Okay, if this is the scenario, then we can solve any problem as x equals to b, a equals to l, okay, u, a, l, u. And look at this properly. The a can be divide or segregate. I use this word segregate into upper and lower. Okay, you can say, can I exchange to ul? Can, but lu is a famous, we use as a lu. Okay, when we use lu, you see, now I'm taking the a x, you see, I'm just replacing, this is, you can take it as a 1, I'm just going to replace this lu inside a. Therefore, it become like this, lu x b. Okay, once it's become like that, I combine these two to solve, okay, and to the problem, you can see that from here to the, in this portion, I just change the ux to the y, where, you look at this carefully, l, y to the b. I didn't change anything here, but instead I just substitute ux with the y. After I've done that, now you can see this one is become a y to the b. Now I need to solve y ux. Right? That means ux first as a y. Okay? And I solve the x first. I solve the x. Okay? Can you see that? Did you get what I'm trying to do here? Okay, we're going to do systematically, then we're going to solve one by one. Okay, now the lower triangulation, diagonal, not triangulation actually, yeah, it's a kind of diagonal triangulation, then that we're going to do. We just name it as L11. Okay, 0, then it will continue. We don't know how many we're going to go. And here we'll do 2, 1. L22, and I come down to whatever level that I can go, and N1, and you can see that it will go on here until L and N. Okay, this is one of the way that I can write L. Okay, can you see that? Then similarly for the upper triangulation, okay, for the upper triangulation, we will just write similar way u11 Oh, just now, yeah, I put the top one. I missed something. Okay, this one is something wrong. Then I need to write first. Then after that, I need to come down. But let's say it's upper. That's why I wonder something wrong. Maybe I should go one more step. Here there will be a sum. Okay, then only it can go up to here. Okay, then it come down. Over here also there should be a one low. That means L. Okay, the L. Please fill up here. Then it never touch the L first. Okay, then it proceed here L11, then something here, then LNN. Okay, then you can see that it come. Okay, sorry. Okay, now here U11, U12. Okay, you take up to U1 and 0, U22. Then you go to the U to end and continue. Then you continue until to the end U, and it will go on to the 0 here up to U and N. Okay, the end you will find NN and you solved. Okay, what is the significance of doing this? Okay, what is the significance of doing this problem? Okay, now we're going to see how do we solve this. Okay, how do we going to solve this? Okay, in this particular case, I will choose crowd methods. For example, similar, there is a, okay, I'll show you both together. Sometimes it's very okay, question can be any way. They can ask crowds or Doolittle. I will try to write both in the both way. First we write in the middle first. Okay, we take it a middle. Okay, let me take it a crowds first. Can you see the crowds? Okay, crowds LU method. But I'm not solving, but I'm just showing how to split. Okay, separate. Okay, how to separate this. Okay, in LU's method here, you can see A11, A12, A13, A21, A22, A23, A31, A32, A33. If I wanted to change it to the LU method, okay, what I'll do, I split this to the LU. Okay, I split this to the LU. You can see that how am I splitting this? A1100 L. Can you see that? Okay, L21, L220, L31, L32, L33. Okay, and you see LU, the you should make it that as a 1. That's a contribution of the crowds. You need to make it a 1. U12, U13, 0, 1, U23, 0, 0, 1. Okay. Okay, now you times and see. Okay, you times this. Okay, you get a, okay, L1 times with this, L11 times with this, whole thing here, you need to times this way. Remember, L1 times with this, you will get a L11. Okay, you go next, this times with the 1, L21. Okay, you get a L21. Okay, you times this with the number 1, you get a L31, no problem. Okay, what about the second one? We go here. Okay, LU. Okay, L11 times with the U12. Okay, here L11, U12. Okay, what about the second one? The second one is L21 times with the U12 plus L22. Yes, that's it. Okay, L21, U12 plus L22. Okay, the third, something similar. you need to times this again. L31 U12 plus L32. Over here, similarly, you need to take a third one, come down, you get a L11 U13. Please, you must master the things here, okay, because during the only problem I just let you know earlier, okay, this is very time consuming. It's easy to do, but it's a time consuming. Therefore, it might be a bit challenging to finish on time. That's why when every year when we give a test or exam for this particular problem, many students won't be able to do it on time. Okay, now come back here again. This L2, this L21 U13 plus L22 U23. Okay, again L31 U13, L32 U23, L33. Okay, this is the what you call Kraut's LU method. What suppose you need to do? You need to match. You need to match to find out the L12, 22 is a arithmetic. Okay, afterward I'll show you one simple example. You just find out. Okay, I quickly write down this. Okay, you just match. You match the results, and after that you find out what is L1, L21, L31 and something like that. Then you manage to find out to the L and U. Okay. Now similarly, I put side by side as I say. Okay, you can see how I have done. Similarly, you can use for Doolittle method. Okay, what is the difference here? Doolittle's. Okay, Doolittle's LU method. Nothing much different. Nothing much different. You can see same question. I am picking the same one here. Same. No difference here. You just choose this to write here. Okay. Again, 1 A12. Okay. I just put it here. LU. Okay. Please copy. Please copy this to this. Okay. Done. Okay. What is the difference? Here you can see the difference. Okay, now we use LU upper triangulation, lower same, we need to use same, but except this part will come to this side. You look at this. Now 1 0 0, L21 1 0, L31 L32 1. Okay. U11, U12, U13, 0, U22, U23, 0, 0, U33. Wow. You get a credit just to move this one to this side, and you get the credits different, different credits. Okay. Then you just similarly you work on this, and where you get something similar but is slightly different, but you can I have a solutions how to transform Doolittle to the Kraut to the Doolittle. Is a 1 minute method. Just you can solve it very fast again, but you start doing again U11, U12, U13, L21 U11. Okay, I'll make it A21 U12 plus U22. Here L21 U13 plus U23. Okay, in this case L31 U11, L31 U12 plus L32 U22. This one L31 U13, L32 can you see U23 plus U33. Okay, now with this one we managed to solve simple concept called Doolittle. This is the different. Okay, this is the different. Okay, for the Doolittle and crowds. Okay, now with that, let me show you one example. We use a Doolittle and example. Okay, after that, at least step by step, we can master the logics of this, what do you call these things. I needed some paper anyway. I didn't expect this finish. Okay, okay, now we go for some simple example. Okay. Okay, we choose one example. Okay, we choose one example here. Example for use Doolittle. Little's LU method. Okay, to solve. Okay, now let's say this 2y plus 7z is equals to 1, 3x 4y plus 5z to this 6x plus 12y plus 3z. Okay, don't expect the question will be given like this. They will give you a problem solving. You need to first build the equation, then only you need to use Doolittle or something. Okay. Normally they won't straight away give you the questions. Okay, they never give you this and solve this. This is a you need to able to solve the problem solving as well. Okay, now for the A, if this is the case, I hope that you already managed to copy. Okay, in this case, if it is a, just pick again. You start doing your matrix. Negative 3, 4, 5, 6, 12, 3 is a LU. Okay, now you need to use Doolittle model to apply and create back. This is time consuming, as I say. Okay, because you need to do every time. Some of them, okay, if it is, I don't know whether this one is given in the formula book. I didn't check that anyway. But assume you should be able to create by yourself lah. Okay, assume you should be able to create by yourself. But since this is this time you are learning online basis, no problem for you. You can just have a look on the solution straight away and you can solve straight away because it's all open books, right? Okay, we cannot stop you from looking at other this thing straight away. You can you create, keep it and just use. Okay, you know, you just need to show the steps anyway. Okay, if they ask you to upload, please show the steps. Okay, and U11 L 21 U11 L 31 U11 U12 L21 U12 plus U22 L31 U12 plus L31 U22. Okay, can you follow? And this is U13 L21 U13 plus U23 L31 U13 plus L32 U23 plus U33. Wow. Okay, 33, huh? Okay, if this, I think you can get ready with that one. Now we equate this equation. We're going to equate this one by one. Okay, your task is to equate this 3, 4, 5, 6, 12, 3. Okay, you get a match. Okay, now you get a match. Want, you want. That means, okay, U11 is equals to 1. Okay, possible? Okay, then U12 is 2. Very obvious. U13 is 7. Okay, what about the LU2111? Because you already know U1 is this. Then L, here you can find out L21 equals to -3. Okay, I hope that you can solve one by one by yourself. And the next one is U22. That means you just need to times with that. I hope that you can do it that by yourself. This is a negative 2, -6. Okay, take it 6 to L2112. Okay, L2112 is a -6 plus U22, which is you get a 4. Therefore U22 is 10. U23 is 26. Okay, you can 20, 21. Okay, yes. Okay, this is how you should start working on. And L, okay, L 31 is a 6, and L32 is a 0. U33 is a -39. Wow. Now create back your LU. Can you follow? Okay, I make it a little bit fast.